Learning Target 1.1, which means Unit 1, Learning Target 1, is to describe the effect of transformations on graphs of parent functions. So first I want to remind you what transformations are. We're going to, in this case, be using either translations when you slide the function left, right, up, or down, and reflections when you reflect it across the x-axis or the y-axis. We'll also deal with dilations, which is when you stretch or shrink the function. So a parent function is the most basic function of that type. We spent all of last year, well, the vast majority of last year working on linear in algebra, and then we spent a little bit of time working on quadratic. Some of you also had some exposure to radical and absolute value equations, but not everyone. We are going to use f of x because we're going to use function notation for this, which just means that y is the same thing as f of x, which means y is a function of x. Now, sometimes they use g of x or h of x. One of the reasons for function notation is because as you get into advanced mathematics, often you're working with several equations at once. So you could have one that's f of x, one that's g of x, one that's h of x, and then you can talk about them and know which one you're talking about. So the most basic linear equation is f of x equals x. Quadratic, the most basic one is f of x equals x squared. Again, these can get more complex, but these are the parent functions. Now, a radical is a root. So like a square root is the most common one you've dealt with so far, but it could be a cube root or a fourth root. So we're just going to deal with two of them. And the first one's going to be the square root function. So f of x is the square root of x. And then the cube root function. So f of x equals the cube root of x. And last but not least, the absolute value function. Remember, absolute value means distance from 0 on a number line, so both the absolute value of negative 20 and positive 20 is both 20, because each of them is 20 units away from 0. So in this case, f of x equals the absolute value of x is my parent function. Now, due to the constraints on actually shooting these videos, I went ahead and set up my tables. So I chose to use negative 2 through positive 3 for my x's there and there. But when I got to the radical functions, I chose in this case to use x values that were perfect squares so I could get integer answers. And again, I only used 0 and positive numbers because in the real number system, you can't take the square root of a negative number. We'll look at other number systems this year where you can. But cube root, I can take the cube root of a negative number. And then absolute value, I went back to the 5 I had used previously. Please pause the video for a minute or two and calculate the y values, or the f of x values, and finish filling in these tables, and then come back. So hopefully you paused the video and finished filling in the tables, and hopefully they ended up looking something like this when you were done. Now, pause the video again and graph these functions on the graph. As it says, it kind of basically extend that graph all the way across. So with the axes where they are, I chose to go by ones, which meant I couldn't fit a couple of these points on my graph. And that's okay, but fit as many points as you can and then continue the pattern on your graph. I will also say I have a difficult time on this thing drawing the curves for some of those and making them look nice, so mine don't look all that hot. Make sure you're using a straight edge for any straight segments or lines that you're drawing, because that is required. So pause and do your graph, please. So this roughly is the graph. Again, my curves aren't looking all that wonderful, but if you graphed these correctly and you went by ones on your axes, this is pretty much what it should look like. So remember these shapes because these are, again, these parent functions that we're going to be dealing with. Now, one thing I did want to remind you of is, and it will come into play with an activity that we're doing, is domain and range and interval notation. So if I look at a basic f of x equals x linear equation, and a linear equation in this case that's not a purely horizontal or vertical line, notice this blue line, it would extend forever left and right. Eventually it's going to hit every x value possible, and since it's never purely horizontal, it always extends vertically as well. So for interval notation, my domain, which is the list of all of the x values, is going to be negative infinity is less than or equal to x is less than or equal to positive infinity. That's interval notation. Where does it stop? Where does it start? Where does it stop? Or in this case, it goes on forever, so that's why I'm using infinity. Range is all of the possible y values, and it's also negative infinity is less than or equal to y in this case is less than or equal to positive infinity. If I look back and I look at, say, the absolute value function instead, yes, it extends forever left and right for x, but it never goes below 0 for y. So if I look at f of x equals the absolute value of x, that parent function, my domain, and yes, I need to label which one's which, is still negative infinity is less than or equal to x is less than or equal to positive infinity. But my range now, 0 is less than or equal to y, but then it continues to go vertically forever, is less than or equal to positive infinity. So when we get to the activity in class, make sure that you know domain and range. Now, if you missed class and you're just taking these notes because you missed class, there is an activity that we started in class as well. So make sure that you get that. Thank you.